This is example 11.11 in the OpenStax Chemistry textbook, second edition. It's worked out there in the textbook if you want to take a look at it. This is my explanation of working it through. So we've got a solution, and we know we have 4 grams of a substance, and we know we have 50 grams of benzene. And we know what the freezing point is. What is the molar mass of this compound? Now, we've gone through a couple of problems previously. If you've watched my other videos, we in the first step, we calculated moles, then we calculated kilograms, and then we calculated the concentration and molality, and then we calculated the change in the freezing point, right, using molality, and then we progress to calculate what the actual freezing point is, okay, of the the solution. All right. Now, in this problem here, we're doing it backwards. We actually have the freezing point, okay, of the solution, and what we want to do is calculate, well, what was the change? We want to now calculate what the molality is. Okay, and using the kilograms also that we have here, we calculate how many moles we have, and then there's an additional step here. We know how many grams we have. From grams and moles, we can calculate the molar mass. Okay, so it's backwards, and let me show you how this works. All right. So first of all, you look up some information about benzene. Benzene is an organic chemical with carcinogenic properties, and we know that for benzene, the pure substance has a freezing point of 5.5 degrees Celsius, and for the pure solvent, it has a Kf value of 5.12. Okay. The molar mass of this thing we're dissolving, we don't know, but we just know we have 4 grams of it, okay? So let's look at all of the formulas and see where to go from this, okay? So the first thing we want to do is calculate the change in the freezing point. Now, you might think it's 2.32, but it's not. Let me show you why. So step 1 here, we use this formula, right? The temperature of the freezing point is equal to the pure minus the change, okay? And the pure benzene melts at 5.5 degrees, I'm sorry, I meant to put that over on the right. The freezing point of the solution is 2.32 degrees Celsius, and the pure, we said, was 5.5 degrees Celsius, okay? And we don't know what the change is, okay? So you do a little bit of algebra there, right? So, I mean, you can multiply all of this by, -1, and you get right, because you have a -1 times a minus, and you can, reverse these so it looks cute on paper. Anyways, I'll just do it on my calculator. So 5.5 minus 2.32 is 3.18. Okay, so we'll make sure you know this formula, okay? So we've got now the delta TF. Now, how is the change in the freezing point related to the molality? That is related based on the freezing point depression formula. So we know that the delta TF is equal to the KF times the molality. And normally we plug in the stuff on the right, we calculate what's on the left. But here, the freezing point depression constant is 5.12. Right, degrees Celsius per molality. And here we are trying to find out what this value is. Okay, we don't know what the molality is. So here it's do this on your calculator. I won't show the math here. 3.18 divided by 5.12 is the molality. Okay, and 0.621 molality. So that's our concentration. Okay, so we calculated the change, calculated the molality. All right, so we got the molality now. Now kilograms of solvent, that's easy to do. We know we have 55 grams of benzene. All right, and you can move the decimal place over 3 times. Okay, and you get this many kilograms of benzene. Okay, so we have molality, we have the kilograms now, and we have the change. All right, so what do I do here? Well, now what you need to do is use the what formula relates molality and kilograms. Okay? And moles. So what we want to do is calculate moles. Let's write down the formula that we've been using all the time here. Okay? Molality is equal to moles divided by kilograms. Okay? Molality, we said we calculated in step 2 as being 0.621. Okay? And we don't know how many moles of the substance we have, but we do know the kilograms. Okay, we have 0.055, right, kilograms. And so we multiply both sides by 0.055. So I'll do this on my calculator. 0.621 times 0.055, and we get a value of 0.0342. Okay, that's, so that's how many moles we have of the solute, okay, of the unknown. So now I know moles. Grams we know. Okay, I don't really have to calculate this. We do know that we have 4.00 grams, okay, of the solute. And now we calculate the molar mass. So the key issue here is that we know molar mass always has units of grams per mole. So we just evaluate this, fraction. So we have 4 grams of the substance, and we know we have this many moles. Okay. So on your calculator, 4.00 divided by 0.0342, and it's 117. Okay, I'll round this off a little bit, and grams per mole. Okay, so that's the molar mass. That's our final answer. So we started with the freezing point of the solution, and we calculated the change. Then in step 2, we calculated the molality. Then in step 3, we calculated the kilograms. And then in step 4, we calculated moles. And step 5, I just recognized that the word problem has grams. And then in step 6, which I didn't really label that in green here, I calculated the molar mass, because molar mass is equal to grams per mole. I have one other example of this if you'd like to take a look at that. Thanks for watching, and please subscribe if you find these videos useful.